Okay, so this is the second installment of the third series of our videos for AC43 Financial Mathematics. And in this video, we will be talking about simple annuity due. So in the first installment of the series, we were talking about, or we were discussing about simple ordinary annuity. So when we say simple annuity, the start and the end of your term is known, and ordinary annuity means the payment occurs at the end of each interval, or at the end of each interest compounding period. Now, also by simple interest with certainty rate, by when we say simple annuity, the interval of payments and the interest compounding period are the same. So that's simple annuity. And then ordinary annuity, again, the payment occurs at the end of each interval. While for annuity due, the payment occurs at the beginning of each interval. So you will just the formula for that will be the same as your future value of ordinary annuity, but with the addition of another 1 plus I. Okay, so this is the formula for that. Let me just delete this. Okay, this is wrong. I dapat FVAD. Future value of annuity due. Okay. Okay, future value of annuity due. Again, so same naman ng formula no. Actually, this part is just your FBOA. So, payment times 1 plus I raised to n minus 1 over I, and then additional lang din tanga times 1 plus I. The reason for that is, di ba, your payment occurs at the very beginning of your period. So, murag na kay extra nga compounding period nga makaanak ang imuhang mga annuity payments. So, for example, Jose wants to retire in 20 years, and for this purpose, he is depositing $200 at the beginning of each month. If you can recall, for our example for ordinary annuity, the payment occurred at the end of each month. Now, for this one, the payment occurs at the beginning of each month in a sinking fund that pays 7.2% compounded monthly. If you will be doing this for 20 years, then how much money will be there for him when he retires? Okay. So payment is 200. I is of course this one. And is 12 times 20. So by replacing our formula with these values, we will be getting 200 times 1 plus I raised to 240 minus 1 over I times 1 plus I. So that should give us 107,392.98 as our future value of annuity due. Now for problems wherein the unknowns would be the payment, the interest, and the or the n, then these are our formula manipulation. So from this, no, we simply have to solve for payment. So with that, we can just simply divide the future value of annuity due with this entire formula. We can also express it like this. Let me just, yeah, you can transfer here already. Okay. So from this one, it will look like this. Equation, script, FV, AD. Future value of annuity due, and the payment is the unknown. So we can just simply transfer everything to the right. So multiplication lang man siya, no? So one possible ni mga scenario for this one would be this one. Would be like this. Okay. Equation, fraction, and then script, subscript. That's FV80 over this entire expression. But then, di ba, what do you call this one? pag, again, atong denominator na as a fractional form, we can kanang transfer that additional denominator there to the numerator by simply flipping it up. So what will happen is we have an or here, or okay, times I. Okay. So what happened here is more about in when we transfer this expression to the other side, our I was transferred to the numerator, and then the rest of our numerators here were transferred to our denominator. So you can solve it like this. But do not forget, Hannah, this one should have like that. Mm, like that. Okay? So um if we replace our formula with these factors, no? So using this one, I think this is what I used here. Let me see. So 107,392.98 multiplied by I. Oh, so this is what I used. Multiplied by I all over 1 plus I raised to the power of 240 minus 1 in close in parentheses multiplied by 1 plus I. So that will give you 199. Um Again, another one would be, but this is more of like more complicated if we use the Excel. But this can be done easily naman using the calculator. So here, from here, what we do is we divide this expression by 0.072 over 12, and then we enclose that. Oh, what happened here? Okay, 0.72. Let me see. Ah, okay. We have to add additional one here, I think. Mm. Yep. Okay. So no matter what way you use, I think this is a lot better because mas lesser ang iyahang mga pag denominator. So you may use this one, or if mas ganahan man ng isa, then you can use that one. So let me just copy this para ma-maintain ang integrity sa formula when I upload this, because again, there are instances wherein mawala siya once I upload it. Okay. So yun, that's for payment. So this is, you have to pay 200 pesos per period. Now, the question is, what if the unknown would be your N, or number of periods, number of payments that you will make? So again, the present value is this one. Payment is 200. Our I is 0.06, which is 0.072 over 12. And our N here is unknown. So this is how we solved for, or we manipulated the formula to come up with the formula for N. So as you can see here, no, our unknown is our N here. So first is we can transfer I, so FBAD times I, and then we can transfer payment, so payment times 1 plus I. So na-transfer na sila sa denominator. Next is we can transfer now plus 1, so negative 1 to plus 1. And then, since kayo na lang siya ang nabilin here, then we can now use our logarithm. So log of this whole expression over log of 1 plus I. So if we calculate this using our calculators, so that's log of, our base here is 1 plus I, so 7 2 over 12. And our, so log of FVAD, so FVAD is 107,392.98. We multiply that by our I, so our I is 0.072 over 12. Over, payment nato is 200. And again, na ate additional nga 1 plus I, so 1 plus 0.072 over 12. And then we deduct, we add 1 to everything. Okay. Oh, what happened here? Payment times power of, okay, sorry. Okay, so what we got is 239.9999 or 240. So this is your formula now for solving for n. So if we translate this to number of years, so this is monthly, so 240 divided by 12, that should give you 20 years. So for periods wherein you have solved na murag dili siya exact, dili siya whole number, you may refer to the first installment of this series on how to translate solved values in n and translate it to t. Okay, so next problem would be, what if the unknown factor is your I, or your interest? So now we will be using interpolation. So just like the first series of this the first uh video of this series, um for interest, for unknown when the unknown value is the interest, you don't have any other choice but to use interpolation. So now we know that our FVAD is 107,392.98. Our payment is 200. Our N is 240. But we don't know. We don't know what rate of interest was used. So again, assumptions. So for point 10, so let's start with 10%. So assuming we start with 10%, no? So 200. So from let me just copy the formula here for us to be guided. Okay. So 200 na payment multiplied by 1 plus I raised to the power of n minus 1 over I. So 0.10 over 12. And then times 1 plus I, which is 0.10 over 12. That should give you a future value. This is a future value. Okay, positive atong exponent here. Future value of 153. So dili siya. So again, no. Same with future value of ordinary annuity. Same ang behavior nila the future value of annuity due. The higher the interest, the higher the future value. So since our goal is 107, which is a lot lower than what we got using 10%, we have to go lower sa atong future value. So we have to go lower sa ato ang interest rate. So at 9%, let's see here, 9%, 9%, 9%, we have 134, still not it. So at 8%, so 8%, 8%, 8%, we have 118, still not it. So 107, so 107.07, so 07 over 12, 07 over 12, 07 over 12, we have 104. So our goal here is 107. So meaning our goal is in between the 8% and the 7%. Okay? So with that, we can now use our high-low method. So with our high-low method, our high here is of course 118, our low is 104, and then our X is our 107, the goal amount. So with that, high-low, so high minus low, and then high minus low. The first one is high minus X, and then over high minus low. And then the difference is the quotient of the difference is 0.81. Same as before. What is our constant? Our constant is high. So our high is our starting point, and we need a percentage between 8 and 7. So in order to get a percentage in between that, we have to deduct something from 8. So muna siya kada itong something na nakuha would be deducted from our 8. So that should give us 7.19. If we go the other route, which is yung numerator is x minus low, so the first one would be x minus low, and then high minus low, and then the quotient of the differences is this one. So our constant is we have to determine again what our constant is. Our constant is low. So since our constant is low, we start at 7. So what do we need to do to get a number between 7 and 8? We have to get the quotient of the differences to our 7. So our rate then is 7.1884% or 7.19%. Then we have to check if the amount is correct or accurate. So we have to start at 7.19. So by using the same formula, we will replace the I here in our calculations with 7.19%. So 7.19, 7.19, 7.19. This should give us 107,261. This is near na sa ato ang target nga 107,392, but we can still explore for possibilities basin ay naapay mas sibo na percentage. So with that, 'di ba? Our at 7.19, our future value is lower than our target. So since we need to get to go higher, we need to add another 0.01%. So let's try 7.2%. So at 7.2, no, replace lang 7.2, 7.2, 7.2. This should give us our targeted amount of 107,392.92. Okay. So for additional problem, no, just additional problems and everything, I'm just gonna show you how this how the future value accumulates in using an amortization table. So this is parang it's just an advanced discussion on chapter 7 or unit 7 of our class, but just to give you another way of solving if you want the longer way, because this is the longer way. So here, no, Jose wants to retire in 20 years, and for this purpose, okay, so let's just assume 5 months para we can look at the progress. Parang we can track the change in our future value without doing the very long na table. So here we can have you have your balance, your payment, your interest, and your total. Okay. So so in this case, this is an annuity due, right? This is an annuity due. So since this is an annuity due, your payment occurs at the very start of the period. So at the end of period 1, your first payment already has anak. So nanganak na siya. So muna siya nga the interest here for one period is 0.072 over 12. So 1.2. So you add everything. So this is your balance before the second payment. So nagbayad kag second payment nimo. So this is your annuity this is your annuity payments, your periodical payments. Okay? And this balance is your payment plus your interest, the accumulated value. Okay. So your interest for the second period is of course your balance at the beginning plus your additional payment at the beginning. Multiply that by the rate. So this should give you an interest of 2.4, an accumulated value of everything. So for 03, so on and so forth. So at period 5, your accumulated value should be at 1018.15. So this is using the amortization table. Let's check it by solving using our formula. So using our formula, 200 times 1.0712 over 12 raised to the power of 5 months lang minus 1 tapos I times 1 plus I. Okay, so this should give you 1.18.14. Okay. So, sir, can we kanang also do an example like this for ordinary annuity? Okay, let's do that. Okay. So this would become FVOA, and so this is at the end of each month. At the end of each month. In a sinking fund that pays 7.2% compounded monthly. Okay. So for this case, let's just transfer it here, the interest. Okay. So still at 5 months, no? Using let's use muna the table kanina we used man the table before the formula. Now, let's change it a bit. Let's use the formula first and confirm it using the table. So here, we no longer include this one because now our problem is an ordinary interest. So our future value after 5 months should be at 1,012 pesos. So here, interest for the first period is 0 still. Sir, nganong zero man siya, sir? Okay. Nganong zero man siya? Because your payment occurred at the end of the period na. So meaning dili pa to siya makapanganak during that period. Kay wala man siya na invest pagka-start. Pagka-end naman siya. So wala pa siya anak lugar, wala pa siya ma-interest. So with that, your balance at the beginning of the period, your balance at the beginning of the period your balance at the beginning of the period is 0 and at the end it's only 200. Your first payment without the anak. Okay? So your interest na dayon for the next period since ordinary annuity ka is only your balance forwarded from last period. Kay imong payment again kay madungagan raman siya imong pagka-end na sa period. So your interest will only be composed of your interest on the beginning balance. So here. Okay. So again, your interest will only be based on the balance, not including the payment. So your payment will not parang give birth to interest in a way kung ordinary interest ka. Magkaanak lang to siya, magka-interest lang to siya pagka next period na. Unlike ang annuity nga pagkabayad mo within the period mga na din siya. Okay? So, as you can see guys, no, if you just follow the formula or you just follow the table, you will arrive at 1012.07, which is the same as our calculation using our formula. Okay, now let's go to present value of annuity due. So this is just the same with our formula for present value of ordinary annuity. The only thing we added is this one. So same siya sa FBAD, no nga, FVOA but with additional. So PVAD is PVOA but with additional. So example, so let's start with amortization. Para mas makita na yung picture out ninyo nga nang ma-zero ang kwarta. So if future value guys, both ordinary annuity nga future value and annuity nga future value, the purpose is to build up money from nothing to something. Now with present value, its purpose is to extinguish a liability. So to have some or to exhaust money. So from something to nothing. If the problem talks about building something out of nothing or from nothing to something, that's a future value problem. If the problem entails there is something na ron, but you want to make it nothing in the future, so that is a present value problem. Okay, so with that, let's take this for example. After down payment of 15,000, annuity payment is 1459.08, paid off in 5 equal monthly payments, paid at the beginning of the period with the interest of 16.4% per year on the unpaid balance. Find the amount of the unpaid balance. Using the formula, no? So using the formula, this is our formula. Using the formula, we have our payment multiplied by 1 less our 1 plus I raised to the power of negative n over I multiplied by 1 plus I. So it should give us 7101.32. So if our principal is 7101.32 and we want to parang exhaust it, diba? From this amount, we want it to become 0. So our payment here, diba? It occurs at the beginning of each period. So with that, ang imong makalculate nga interest na so marami tawag this is very wait lang ha. Okay. Wait lang. So I think this is done correctly but like shown na parang hindi niya ma-translate ng better yung let me just try another table here. Period 1, 2, 3, 4, 5. Okay, so balance. Let me just add something here. So 0. Balance is at 7101.32. Our payments is at okay. And then our interest for the period. Okay. Mm. Um, mm, okay. Okay. So now, our interest for period 1, again, kaya 'di ba? Let me just delete this camera. This will make you confused. Okay. Let's transfer you here. Okay. So, okay. So your interest for your since your payment occurs at the start of the period, murag ang imong kanang basihan sa interest will already be deducted by your payment. So your interest now will be equal to the interest on the net amount. So the balance at the period minus the payment at the beginning of the period, multiply that by our interest rate of 0.164 over 12. That should give us 77.11. And our balance then will be this one plus your interest minus your payment. Okay, again, your payment is to extinguish. Unlike sa present value, sa future value, di ba nga, you're adding. This one, sa imuhang payment, as imong utang, interest is addition to your utang, mo nang add interest, but your payment is a deduction to your utang. So, minus payment. So, muna siya imuhang kuan. So, again, the interest is calculated on the difference of the principal at the beginning balance, and then minus your payment. So, ayun. And then your balance would be your balance at beginning plus the interest minus your payment for the period. So if we continue that, no, our liability will become zero at the end. Okay. So, sir, can we also have an example of a problem na with amortization but ordinary annuity? Okay, so let's do that. Mm-hmm. Sorry. Do that. Okay. Let me just remove this extra cells here. Okay. So, after a down payment of 15,000, annuity payment. So, at the end of the periods, at the end of the period. So, again here, let's start muna using the formula because that's the quickest way that we can solve this one. So again, same thing except for this part. We will remove this part because this has now become a present value of ordinary annuity. So let me just be clear about here. Present value of annuity due. This one is a present value of ordinary annuity. So, yeah. Okay. So with that, our principal is at 705.57. Now, since our ato na siyang i-move na dayon, this one, let's move this one. Since our payment only occurs at the end of our period, meaning katong beginning nimo nga balance sa primero, mga anak to siya for the whole period, dili siya mabuhinan. Unlike sa imong payment ka nagsugod sa murag imong bayaran primary sa pagsugod mo tong mabuhinan na imong base for interest. But since ordinary annuity means imong payment at the end of the period pa, makapanganak na to imuhang balance, aya ka makabayad. So with that, our interest will be based on our principal na lang dayon or our balance at the beginning. So we will just remove this one. So this is our interest na. And then, our balance will still be the same. Our principal plus the interest minus the payment. So as you can see guys, it will still give you a zero. So after 5 payments, diba, ma-zero ang imuhang utang. So this is like a confirmation kung sakto ba imong na-solve na present value for this one or future value for the other one katong sa kani sila diri. Okay? So now let's move to a longer problem na, not just 5 months but for a longer period of time. So after a down payment of 15,000 and a payment of this one, beginning of the period, Okay, so let me just copy our formula here. Okay. So using this formula, no, we can now solve for the present value of our annuity due, which is at 1459.08 times 1 less 1 plus I raised to the power of negative n over I plus 1 plus I. Okay? So that should give us a present value of 60,291.66. Now, what if the unknown value is our n? This is for payment, right? So what if our unknown value is our n? O let me just show you na lang muna how unsa ang ato ang dili pa dai. What if our unknown value is our payment? So what if our unknown value is our payment? You can either express the formula as this one. So PV80 times I over 1 plus 1 plus I raised to the power of negative n times 1 plus I, or using this one. But I prefer this one para mas gamay lang imuhang fractional. Murag fraction within a fraction. Murag mawala siya na expression within our formula. So, this was murag manipulated in a way na, if you can see here guys, PVAD, so our unknown is payment, so we transfer I, so I to the other side, so na-multiply na siya. We transfer these two, the 1 less 1 plus I raised to the power of negative n, and the 1 plus I to the other side by making them denominators. Okay? So with this formula, now we can now solve for our payment, which is, so our PV AD, present value of annuity due here, is 6291.66 times our I of 16.4% over 12 all over 1 less 1 plus I raised to the power of negative 60 times 1 plus I. So that should give us a payment of 1,459.08. So now the next problem would be, what if the unknown value is our n, or the number of periods, the number of payments that we will be making. So from this formula, so this is our original formula for PVAD. So our unknown is n, so we transfer we transfer this one to the other side. So we eliminate other things that can be eliminated, and then retain those that has the n na kana n uh, uh, value. So with that, no, so PVAD, so we transfer I to the other side, so that's times I. Payment and 1 plus I will be transferred as denominators to the other side. Now we are left with this expression na 1 less 1 plus I minus n on the other side. So to change our operation from negative to positive, we transfer this one to the other side. So, namin mo na siyang positive 1 plus I raised to negative n. And all this expression will be transferred to the other side. So, may mo siyang minus PVAD times I over payment times 1 plus I. And then, we want our n to be on a positive operation. So, we transform the 1 plus I raised to the power of negative n to 1 over 1 plus I raised to n. And with that, we can then transfer 1 plus I raised to n to the other side by making it a numerator. And then this whole expression here, so nagbaylo sila, will become now our denominator. So with that, our final formula na dayon for n is log of 1 over 1 less PVAD times I over payment times 1 plus I all over log of 1 plus I. So if we use our calculators, given these values, no? So log, our base here is 1 plus I, so 0.16, 4 over 12. And our expression here sa ato ang numerator is 1 over another fraction, napaday, 1 over 1 less another fraction. PVAD is 60,291.66. Multiply that by our I of 0.164 over 12. And then all over payment of 1459.08. 0.08. multiplied by 1 plus I. So that's 1 plus 0.164, 0.164 over 12. Okay, that should give us 60. So 60 payments, or a total of 5 years. So again, same with the ano, say for example, no, what you got is not a whole number. So you may revisit our discussion for PVOA when your calculated N is not a whole number. So to translate that into years. So that's how you do that. And now lastly is we will now go to the discussion for interpolation. So same with FBOA, PVOA, FVAD, PVAD, when the I is unknown, the only thing that we can do is through interpolation through high-low method. So again, for high-low method, we have to remember our formula here and apply this formula accordingly by assuming certain percentages. So let's start again at my favorite number, 10%. So 10% here. So our payment is 1459.08. So 1 less 1 plus 0.10 over 12 raised to the power of negative 60 all over I 0.10 over 12 multiplied by 1 plus I of 0.10 over 12. Okay, so that should give us 69,244. Our goal is only 60,291. So since this is a present value, no? So for present value, the higher the interest, the lower our present value. So since we need to go lower, we have to increase our interest rate. So let's try at 12%. Kay layo kasi 69 o 60. So let's jump by 2% no, for 2 percentage points. So at 12%, this should give 12%, 12%, and 12%. This should give us 66. Still not it. So let's try. Oh, I already tried 15. So let's try 3% nga increase. Kaya layo pa pud kaayo si 66 and 60. So how do you determine ba nga noon sa kadako ang imuhang need na iambak? So if you can see here guys, the difference by just a 2% increase is at almost 3,000. And we need to go down by additional almost 6,000. So with that, additional 2% will just give you around 3,000 nga decrease. So that's why we can increase by 3%. Para mas dako-dako ang ato ang decrease nga mahitabo. So muna siya nga from 0.12, I went directly to 0.15. So using 0.15, we'll have 0.15 here, 0.15, 0.15, 62,098 dool-dool na ta. So let's just increase it by 1% na dayon. So increasing it by 1%, we have 60, we will have 60, so 16, 16, and 16, we will have 6799.87. Still, mas dako pa siya. We still have to go lower. So we have to go to 17. So by using 17%, so 17, 17, 17, our present value in 17% is 59,541. So with that, our target of 60,291.66 is between 16% and 17%, or between 60,799 and 59,541. So now we can now use our high-low method. So our X is here and our high and low are here. So first with our high X, high-low. So high minus X, and then so high minus X and high minus low. So the difference, the quotient of the difference here is this one. And then our next task to do is to determine our constant. Our constant is high, so we start at 16. So since we need a value between 16 and 17, we need a value between 16 and 17. And our starting point is 16. That means we need to add whatever we have gotten to 16. So this should give us 16.40%. So 16.40%. Ay, 40. Okay? Now, on the other route, so if you want nga si low ang atong constant, so x minus low, high minus low. So we have x minus low, and then high minus low. The quotient of the differences is this one, and our constant is low. So our constant is low. With our starting base is 17%, and we need something in between 16 and 17. That means we need to deduct whatever we have gotten to 17. So this should give us 16.4%. So by using 16.4%, let's try and see if we will arrive at our target amount. So at 16.4%, 16.4, 16.4, 16.4, we have actually arrived at our exact amount. Okay? So, if dili yun ma-arrive ang exact amount, no, do the trial and error, and then just the factor nga nearest jud sa imuhang target amount. Okay? So, with that, we're now done with the second installment for this series, PVAD. If you have any questions, please don't hesitate to contact me through our GC. Um, um, uh, and also, reminders for everyone, your assignments will be given within the week, which it will be due probably early next week. And then after that, we will have your last unit drill during midterms, and then we will now prepare for your long exam and your midterm exam. Now, before the long exams will be given, for those who have missed your quizzes, please contact me to take your special quiz. Again, the only quizzes I can give you are your unit quizzes, because the answer key for your assignments have already been uploaded. Before the post test will happen, I will be uploading the answer key for all the unit tests, and once that is uploaded, apologies, I won't be able to give you special exams anymore. So if you have any concerns, please do not hesitate to contact me. And I hope that you have learned something today. So thank you so much, guys. Have a great day.